All right, class, welcome to section 7.3, hyperbolas. So we're continuing our discussion on the conic sections, and the next one's the hyperbola. The hyperbola is a collection of all points whose difference of distances from two given points is constant. So kind of similar with the ellipse. The two given points, again, are going to be called the foci. And this time the difference of distances will be constant. So I know in this picture there's a lot of colors, a lot of lines. So I'm going to show to you which one is actually the hyperbola. It's these two parabola looking shapes that are back to back. So as I did mention in 7.1, an hyperbola is actually looking like a V. The parabola looks more like a U. So as we'll see, the hyperbolas become linear. Whoops. The hyperbolas become linear. So it's almost, what the heck? It's almost looking like a V, except for, so from here on out, it's just going to look like a line. Yes. And then you have another one backed up to it. So I know it doesn't look good, but again, it's just like a rounded V at the edge. Okay. All right, so that's what hyperbolas look like. We'll draw a whole bunch today. All right, so now it says the difference from any of these points to the foci are the same. So if I pick any point on the hyperbola, there's the hyperbola, and I measure the distance to one focus and to the other, and I subtract these two distances, that's the same as being here, measuring the distance to here and subtract them, the answer will be the same. Okay, so from any point on the hyperbola, if I measure the distances to the two foci and subtract those two numbers, I will keep getting the same answer. All right. So let's see what are some of the features. Let me clean this picture up as it has enough color already. So let's see what are some of the features of the hyperbola. So, of course, the hyperbola will have the two foci that it wraps itself around. And here is one focus, and here is one focus. So I'd like to point out that in an ellipse, the foci are inside. In a hyperbola, the foci are also inside the shape, except for the shape opens up differently, right? But the foci are inside the shape both times. Okay. All right, so here are the foci. Now, the edges of these two sides of the hyperbola are called the vertices. So one vertex and another vertex. So same as an ellipse, we will have a focus, we'll have a vertex, we will have co-vertices. Okay, and then we'll see how we can get to those. And of course, same as in a circle, same as in an ellipse, the hyperbola also has a center, and the center is exactly halfway between the foci, halfway between the vertices, and halfway between the co-vertices. That's called the center of the hyperbola. Now, as I mentioned, the hyperbola becomes linear. So at some point, this shape will just follow the shape of this line. So that's what asymptotes are for. Asymptotes are lines that the graph gets closer and closer and closer to, and it's just not going to touch it. Same as our rational functions. The graph just at some point became linear. It kept going, almost resembling a line, right? Okay. So, what else? We have in an ellipse, we had a major axis and a minor axis. Here we have what's called a transverse axis. That's the line between the vertices. So it's the axis that has the center, vertex, and focus. We call that major axis in an ellipse. And we have a conjugate axis, which is basically the equivalent of a minor axis for the ellipse. Now, you don't really need to know these names. I'm not going to say where's the transverse axis, where's the conjugate axis, but you definitely should be able to understand what the vertex of a hyperbola is, what the focus, and what the center is. And we'll also talk about how to find these two asymptotes. Okay, so number one, what does the equation of a hyperbola look like? So same thing, we will first start with a hyperbola that's centered in the origin. So as you see from these two pictures, the hyperbolas are either going to open left and right alongside the x-axis, or the hyperbolas can open up and down alongside the y-axis. So what's the difference between these equations? The equations are very similar with the equations of an ellipse, except for, because remember how we even got this started, that the difference between the distances from two given points is constant, whereas in an ellipse we had the sum of the distances being constant. So in a hyperbola, we will have a minus sign instead of a plus sign. So if the equations have the x being positive, then the hyperbola will open left and right alongside the x-axis. If the equations have the y being positive, then the hyperbolas will open up and down alongside the y-axis. Okay, and then we'll talk about what A, B, and C are. So I'm going to talk about those next. Now, if you see, I have put A always under the first term because in an ellipse, A was the biggest number. It doesn't have to be anymore. A, just like with the ellipse, is simply the distance between the center and the vertex. Now, and that vertex is on the x-axis, the A will go under the x and it's going to be positive. Here it is. Here's the vertex, here's the center, and this distance is an A. Now, if the vertex is on the y-axis, then the A will go under the y because it's a chain. It's how many units we go in a y direction. Okay. Now, the B value will be the other one, the distance to the co-vertex. So that B value, again, it doesn't mean it has to be the biggest. Okay. But it's with the second, the negative term always. Okay. And just like we had with the ellipse, the distance from the center to the focus is going to be called C. And here it is. Now again, the focus is past the vertex. Okay. And it's on the same axes with the center, vertex, and focus. They're all on the same line. Again, it's called a transverse axis for hyperbolas. And we need that equation that connects A, B, and C. Now, for an ellipse, we had the A squared is equal to B squared plus C squared because A, as you saw from all the examples we've done, all the discussion we've had, for the ellipse, A was the biggest distance. However, whoops, that's what I meant to do. For the hyperbola, which one's bigger? Well, as you see, C goes past A. C goes past A, and it's actually more than B as well. So in this case, C squared is the biggest one. And so C squared will equal to A squared plus B squared. And actually, it's right here as well. Okay. All right. So we'll keep practicing on these concepts, and with practice, we'll learn about it. Okay. And same thing, if the center is taken away from the origin, but it's put to some kind of H and K coordinates, then we'll have to subtract those from X and Y. So again, depends whether the the hyperbola is opening left and right along the x-axis, or up and down, along the y-axis. But in either case, as you see, I'm subtracting the x-coordinate of the vertex from x and the y-coordinate of the vertex from the y's. Okay, that's not going to change. All right, so let's see how we can get used to these concepts. It says graph the hyperbola, give the coordinates of the center, vertices, foci, and the equations of the asymptotes. So I will show you in a minute how to find all of that. Now, of course, the equation of a hyperbola, same as the equation of an ellipse, has to somehow look like this, with the fractions, as you see the minus sign in between, and equaling to 1. That's not the case here. So, same as we did in the last section, we're just going to manipulate it to make it look like that. So I'm going to add 36 over, now at least it's equaling to a number, but it has to equal to 1, so I divide everything by 36. So here's the equation, nicely reduced. X squared over 4, because 9 and 36 reduced by 9, leaving me with a 4, minus y squared over 9 equals to 1. So this is a definitely more useful version of this equation. Okay. So we'll start with the center. All right. The center is, we're looking at what's subtracted from x and what's subtracted from y. And so since we haven't subtracted anything, that means the center is at 0, 0, right? In other words, the origin. Great. And we'll do the same thing we did for the ellipses. Under the x, you see a 4. So in an x direction, we'll go by the square root of 4 left and the square root of 4 right. So again, what's being squared there? It's a 2. In a y direction, I see a 9. So 9 is 3 squared. That's where I'm going 3 units up and 3 units down. Now, if this was an ellipse, I would just connect these 4 points. However, it's a hyperbola. So, let me show you what we'll do. We'll use these points to draw a rectangle. We'll use the rectangle to draw its diagonals. Now, these diagonals are the asymptotes of the shape of the hyperbola. Okay, now, look at this. Let me show you back. The hyperbola either opens left and right or up and down alongside these asymptotes. So at this point, it may not be clear just from the picture where the hyperbola will open, but I'll tell you where it opens. It opens left and right alongside the x-axis, and that's because x is the positive one. Okay, there it is. So now let's answer more questions. Where are the vertices? These are the vertices at the edges of the hyperbola. So as you see, they're at plus, minus, 2, and 0 as they are on the x-axis. I didn't ask you for covertices, but if I would have, there would be the points at 0, 3, and 0, negative 3. I would like to know where the foci are, so we'll figure that out. But what are the equations of the asymptotes? So here it is. An asymptote is a line, right? So let me show you how we would get that. Well, the line, any line has the form y equals mx plus b, as you remember from chapter 2. Yes. So if you look at these lines right here, what do you notice? What's b? What's the y-axis intercept? The y-axis intercept is a 0, so that's all I have, mx, right? The b is 0. Now, to read the slope, I have to think about what's the rise versus what's the run. So as you see, to draw this line, I went 3 units up and 2 units to the right. So the slope is 3 over 2, okay? The other slope for this line that's going down is 3 units down and 2 units to the right. So the equations of the asymptotes are plus minus 3 over 2. So don't worry about memorizing any formulas. Don't start writing A's and B's and whatever nots, because you're not going to remember these formulas. I'm not going to put these formulas on your test. I will definitely put the equations for the hyperbola, ellipse, circle, and parabola for you, but not the equations for the asymptotes, because you don't need a formula. You've learned about lines and you can easily read. Here, I'll put it in parentheses. You can easily read the equation of a line. We've learned about this. And you could read it off the graph, so you don't need formulas. All right, so those are the asymptotes. The equations of those lines. And then one more thing was the focus. So where's the focus? The focus is somewhere inside the shape, okay? So if anything, the foci will have a y-coordinate of 0. Now, what I need to do is I need to find that c distance from the center to the focus. So here it is, and I have some room right here. So c squared is a squared plus b squared, which are these two numbers. So it doesn't matter which one's smaller and which one's bigger. As we add these quantities, and therefore take the square root on both sides, so plus minus square root of 13. So the foci are at plus minus square root of 13 and 0. Okay. All right. So now that we've gone through it one time, let's try again. The center is in the origin. Again, I know that because nothing's subtracted from x or y. Look, in a y direction or under y, I see 64. 64 is 8 squared. So in a y direction, I have to go 8 units. Whoops, 8, 1, 2, 3, 4, 5, 6, 7, 8. 8 units up and 8 units down. In an x direction, I see 36, and that is 6 squared. So I'm going to go 6 units left and 6 units right. And again, I'm not connecting these points, but I am with an ellipse, but I'm using them to draw a box. And I'm using that box to draw its diagonals. And those diagonals are the asymptotes for the hyperbola. Okay. What color should I use? I'll put green. Okay. Now, because y is positive, this hyperbola will open up and down alongside the y-axis. So it kind of interferes with my next equation. It's quite big numbers, but there it is. Okay. So where are the vertices? The vertices are up and down at the edges of the hyperbola. They are at 0 for x and plus minus 8 for y, as we are on the y-axis. The asymptotes have equations y equals plus or minus 8 units up, 6 units to the right, x. This, of course, reduces to plus or minus 4/3 x. Okay, and again, the b is 0 for all of these. Foci. So to find the foci, c squared is a squared plus b squared, which is going to be 64 plus 36, which is 100. So c is plus minus 10. Okay, so I'll write them up here. The foci are also on the y-axis. So x is 0 and y is plus 10 or minus 10. Okay, that was a big shape. I had to kind of get out of it. All right, this is it. Now we're just continuing with the same things. So first things first, where is the center? Be careful. X goes first every time we write ordered pairs. So I have to read what's subtracted from x and what's subtracted from y second. So I'm going to start this at -2, +1. Here is the center. Okay. Now in a y direction, I have to go 2 units up and 2 units down. In an x direction, that's 25, so 5 units left and 5 units, to the right. I went too many points. This is 2 points down. Okay, so I'm using these points to draw a rectangle, and I'm using this rectangle to draw its diagonals. Those diagonals are the asymptotes. Okay. So, because y is the one that's positive, this hyperbola will open in a y direction. So therefore, from this vertex, alongside these lines, up and down. There you go. That's the hyperbola. Okay, so the center, the vertices are easy to read. I can read one, and again, because we've shifted it off the origin, just use your pretty graph to see that the vertex is at -2 and then +3. And the other vertex is down at also at -2, but down at -1. So again, to 1, we added 2 and we minus 2. The asymptotes, here's the trick of writing asymptotes. The fact is that you would not know what the b is not 0 anymore, right? These asymptotes are crossing somewhere. We're not so sure why. But it's just the same as if you would shift them back to the origin. So instead of y, I write the y minus 1 is equal to mx. So again, that already takes care of the shift and the b. So instead of x, I'm going to write x plus 2. So copy, instead of x and y, copy these exact parentheses. And for the m, you're just going to read again what the slope of this box is. So from the center, we went 2 units up and 5 units to the right, or 2 units down and 5 units to the right. So that's it. Again, no formulas needed. You could just read the slopes off the graph. And finally, for the foci, which are somewhere here and somewhere here, we're going to have to find that c value first. 4 plus 25, which is 29. So C is plus minus the square root of 29. So we'll write this compacted. So the foci, as you see, the x-coordinate of the focus is the same as the x-coordinate of the center or the vertices. They're all on the same vertical line. But from the center, which was a 1, we would have to go up and down by a square root of 29 units. So from 1, which is again where we start counting everything, from the center, we would go up by square root of 29 units and down by a square root of 29 units. So we leave that like that. All right. And last one. There's a y under there. Okay. So the center is at -1, -2. -1, -2, here's the center. Under x, I see 16, so I'll go 1, 2, 3, 4 units left and 4 units right. Under y, I see 9, so I'm going to go 3 units up and 3 units down. And again, I'm using these points to draw a rectangle. And I'm using this rectangle to draw its diagonals, which become the asymptotes of the hyperbola. Because this hyperbola has x that's positive, it opens left and right along the x-axis. Okay. So therefore, here are the vertices. So I'll read the coordinates. One vertex is at 3, -2. And the other vertex is at -5, -2. So they're all on the y equals to -2 line, which is our transverse axes. The asymptotes, or instead of y, you're going to write y plus 2, is plus or minus the slope we'll read, and instead of x, you're going to write x plus 1. So what's the slope of these lines? We went up 3 units, and to the right 4 units. So 3/4 and minus 3/4. And that's it. Foci. So c squared is a squared plus b squared. So we'll just take those two numbers. Take the square root, and you'll get 5, plus or minus 5. So the foci are going to be 5 units in from the center, so we actually know what that is. So 5 units in from -1 will be at 4, -2. And 5 units down from -1 will be at -6, -2. Now again, if this is an integer value that we get to add or subtract, we know what -1 plus 5 is. We know what -1 minus 5 is. Of course, we also would know what 1 plus the square root of 29 is if we put in the calculator, but we don't have to. We could just keep it an exact value, in other words, with the square root. All right. So, just like we did with the other shapes, we're going to go backwards. And just like we did with the other shapes, even though it doesn't say to, it really helps to draw, not a pretty, doesn't have to be pretty, but we just have to get an idea. So it says, find the equation of a hyperbola with vertices at 0, 6, and 0, -6. So immediately that tells me the center is halfway through, and then my hyperbola opens up and down. So because the hyperbola opens up and down, the vertices are on the y-axis, then the y is the one that's positive. The center is at 0, 0, so I'm not subtracting anything from x or y. And I already know this a value is going to be 6, so that's what goes under y. Okay. We know that there is a focus at 0, -8. So therefore, we know that the C value is 8, the A value is 6. So I have enough information to find the B value. So we know C squared is A squared plus B squared. So 8 squared is 64, 6 squared is 36. So that's it. I'm going to find B squared out of that. Really quick, 64 minus 36 is 28. So that's what goes under here. 6 squared, of course, we know is 36. And here's the equation. Find the equation of a hyperbola with vertices at 0, -2, and 6, -2. So I have one vertex here and one vertex there. Okay, so therefore the center is halfway between them. So that's why a picture is so helpful. So halfway between 0 and 6, without even a midpoint formula, you guys know that's going to be a 3. So you see that the center is at 3, -2. The other thing you see, because the vertices are here, that means the hyperbola opens left and right. So x is positive, y is negative, the center is at 3, -2. So instead of x, I write x -3. Instead of y, I write y +2. And now, we already know what's the distance between the center and that vertex, the a value. So the a value is 3, and it goes in an x direction, yes? So now I have to, again, try and figure out that b value. So same thing as with the problem above. We are given the coordinates of the foci. One is at -2, -2. The other one is at 8, -2. So therefore, I could tell that the C value is 5. So there's 5 units. There's 3 units from the center to the vertex, and then an additional 2 units to hit the focus. So 5 units for that. So A is 3, C is 5. So 25 is 9 plus b squared. Therefore, b squared is 16. So that's what I put here. And that 3 squared is a 9. So it's to look like Christmas on my paper. All right, here it is. So yeah, I didn't leave myself too much room. Do that for yourselves at home. Make a nice, pretty picture. And that will answer all your questions. Okay, so one more. This hyperbola, number 1, immediately I can tell you opens up and down. So first things first, y is positive, x is negative. The center is at -1, 0. So, of course, I don't have to subtract, y minus 0 is y, so therefore this is just the y squared. So whatever the x-coordinate is for the center, we subtract that from x. Whatever the y-coordinate of the center is, we subtract that from y. All right. Now I immediately could see what the A value is. A is the distance from the center to the two vertices. So we had to go 3 units up, right? Because we went from 0 to 3 or 0 to negative 3. So immediately I know the A value is 3. And yet again, the same type of question. I see that the foci are a 3 square root of 2 up and negative 3 square root of 2 down. So in other words, the distance from the center to the focus is a 3 square root of 2. A, the distance from the center to the vertex is 3. So we need to, yet again, find the B value. So one more time, c squared, c being the longest for the hyperbola, c squared stays by itself. When I square a 3 and a square root of 2, let me show you what we get. You can even put in your calculator, but squaring the 3 gives you 9. Square the square root of 2 and you get a 2, so 9 times 2 is 18. So b squared, therefore, is 9 as well. Okay. All right, now here's the last question, which again will ask us to find the equation of a hyperbola and sketch the graph. And so it says a hedge is to be constructed in the shape of a hyperbola near a fountain at the center of the yard. So find the equation of the hyperbola and sketch the graph. We know that the hedge will follow these asymptotes. So we'll put the center in the center of the xy plane, the center of the yard. The asymptotes have equations y equals 2x. So the slope is 1, yes? And y equals to negative x. So plus minus 1 are those slopes that we were counting. Then it says its closest distance to the center of the fountain is 5 yards. So here is your hedge. All right. So I drew the picture already. I drew the asymptotes for you, these 2 lines, so we already know how to draw lines. The hyperbola has to follow those lines, but it turns at the vertices, yes. And then the way I pictured, and again, it could be up and down, it wouldn't be wrong. Maybe you thought to put the hedge up and down, no problem. Whatever's easiest, it didn't say it has to be, oriented east-west or anything like that. So the point is, the way I oriented it, the x is the positive one. The y will then be the negative one. Under the x, we have a 5 squared, so clearly 25. Now we need to figure out what y is. So, I'm sorry, what b is. Now, knowing a and b earlier, knowing a and b, we drew these boxes and we found our asymptotes, yes? But we already, this time we have the asymptote. So the fact that y equals to x is the line simply means that this box is going to go the same distance to the right as it does up. So 5 over 5, right, 5 units up and 5 units to the right would get me that slope of 1. Or 5 units down and 5 units to the right will get me that slope of 1. So because the slope is 1, the A value and the B value has to be the same. Okay, so there you go. The A's and the B's are going to be the same. All right, and this is it.